Good morning everyone. Here we are going to see some of the reactions of the carboxylic acid. So when carboxylic acid is treated with the PCl5, a halogenating agent, or PCl3, SOCl2, like any of the species, what happens? The substitution takes place. This hydroxyl group is substituted by the halogen and it forms acyl halide along with the phosphorus oxachloride and HCl. This is the general halogenation. That means the exchange of hydroxyl takes place with the help of the halogens. But what happens if you are treating the carboxylic acid with halogen and red phosphorus? When you will treat it with the red phosphorus and halogen, it will undergo a unique halogenation. That means the halogenation will take place replacing the hydrogen, that is called the alpha hydrogen. That means 2-chloroethanoic acid. And this reaction is well known as Aldehyde-Zelinsky reaction. So this is the Aldehyde-Zelinsky reaction, generally called HVZ reaction. Then this is the HVZ or the Aldehyde-Zelinsky reaction, an important reaction or name reaction. Now we are seeing the reaction of carboxylic acid with the ammonia. This is the carboxylic acid, a well-known acid, and ammonia is also a well-known base or Lewis base or the Bronsted-Lowry base, that is the proton acceptor or electron donor. So in this case, an acid will react with base and will form the salt. So this is the compound CH3COONH4. This compound is called ammonium acetate. But if you are proceeding the same process in presence of heat, सेम रिएजेंट रखिए, अमोनिया रखिए, कार्बोक्सिलिक एसिड रखिए, लेकिन हीट कर दीजिए, देन व्हाट हैपेंस? द लॉस ऑफ वाटर टेक्स प्लेस, ऑक्सीजन एंड 2 हाइड्रोजन्स, एंड ड्यू टू द लॉस ऑफ वाटर इट फॉर्म्स amide. So in absence of heat, it is the ammonium salt which is formed, and in presence of heat it turns in the form of the amide. We are now going to see the decarboxylation reaction. Here I am seeing the decarboxylation with the caustic, with the sodium hydroxide. This is the base, well-known base and acid. And when the reaction will take place, it will be the neutralization reaction, that is the CH3CH2COONA along with water. I am not writing the water here. Now this compound is when retreated with the sodium hydroxide and heat, what happens? The decarboxylation takes place, that means the loss of sodium carbonate Na2CO3 takes place. So with the compound sodium carbonate takes place, that means sodium and oxygen from somewhere here and NaCO2 from here. Then what remains? It remains CH3CH2 along with this hydrogen, it becomes an alkene. That means it forms a compound having one carbon less than the parent carbon and the product is alkene. This is one of the few reactions in which the number of carbons decreases by 1. Actually in your syllabus only 2 reactions are there. The first one is the decarboxylation with the help of the sodium hydroxide, and second one is the Hofmann bromamide degradation. So in these are the 2 reactions you can see that the loss of carbon takes place. The product carbon chain have one carbon less than the parent chain. Now we are going to see the same reaction, that is the decarboxylation reaction in the presence of the calcium hydroxide. What happens when the calcium hydroxide is treated and the decarboxylation reaction results? So here is the carboxylic acid and diacetic base, that is the calcium hydroxide. Now in this reaction, 1 calcium hydroxide will react with 2 moles of the acetic acid, and after reaction this one will be the salt, that the calcium ethanoate. When you will heat the compound, the loss of calcium carbonate will take place. I am just trying to show that the calcium carbonate is somewhere here. The loss of calcium carbonate takes place, and after the loss it will form CH3COCH3, that is the acetone or the propane 2-one along with calcium carbonate. The last one is the electrophilic substitution reaction, the last reaction of the topic. The carboxylic acid undergo electrophilic substitution reaction, but not as frequently as that of the benzene, as that of the other species which are capable to give the positive resonance. As carboxylic acid gives the negative resonance, so it is a deactivating group, it is a meta-director group. So whatever the next species approaches on the benzene ring, that approaches on the meta position, and the rate of reaction is very slow. It's enough for today. Next day we will discuss about the next chapter, that is the compounds of nitrogen.